afternoon, everybody, and welcome to our fourth in the series of space webinars. On behalf of Beca and SpaceBase, as I said, welcome to our series focused on space and the information domain within a New Zealand context. I'm Brendan Pett, the Operations Manager for Trans-Tasman Defence and National Security and the Beca Lead for Space. Last month, for those who may have joined us, we had the pleasure of hearing from two innovative New Zealand companies, Beca and PlantTech, who talked to us about the application and use of space-based data. Today, we're excited to have Zeno Astronautics and Extraterrestrial Power, two New Zealand-based commercial startups, talk to us about their experience in the space domain. So I'll hand you over to Jess Tucker, your host for today's webinar, who will guide you through today's session. So over to you, Jess.
Thanks, Brendan. So as Brendan said, this is the fourth in our series of webinars, and today we'll have speakers from Zeno Astronautics and Extraterrestrial Power, two startup companies working with space technology. Again, we've got a few more in attendance than we had just a minute ago. So to attendees and participants, really like to turn your attention to the Q&A panel at the bottom of your Zoom webinar screen, and please use that to submit questions to be reviewed and answered by our speakers. They'll have an opportunity to either respond in text in the chat, you'll see that, or to flag questions to answer live at the Q&A session at the end. So with our first speaker, Max Arshafsky is the founder and CEO of Zeno Astronautics. Max lives for change and making things drastically better. Accepted into Russia's most prestigious physics university, at age 18, he instead decided to move to New Zealand, enrolling in commerce and engineering degrees and managing multi-million-dollar property projects. Max is now building the company that will underpin the future of generating and controlling force in space, with applications ranging from satellite positioning through to accelerating payloads between planets. Please welcome Max Arshafsky.
Thank you, Jess. Lovely introduction. Great to be here. I guess I'll start with a brief summary of what Zeno is before I go into the slides, and how we ended up, being in the position at which we're at currently today. So Zeno is a Auckland-based astronautics company. We're roughly four and a half, maybe 5 years old since incorporation. We started out with within the University of Auckland, space program within the University of Auckland, and started with a simple challenge which was presented to us at the time, which is look at the current state of the space industry, look at the most challenging bottlenecks that are present there in the space industry, and look at the ones that will continue to be even more restricting going forward as the space industry develops, identify them, and potentially come up with a solution to these problems. And when we looked at this industry as a whole, so to speak, we realized that a large proportion of the entire value that is derived from being from going to space is actually comes from the ability to do useful things in space. It comes from the ability to use a spacecraft in a meaningful way, to point them and to ensure agility in general for the spacecraft. All of it essentially boils down to an ability to generate a particular force in space, and so that this force can be used for the benefit of spacecraft that are doing the actual useful work in space, such as taking images, communicating, and so on and so forth. And the mission, or the statement of Zeno in general is that we work and bring this new force to the space industry, a force which is very capable and that can be applied to a whole range of problems. It is a surprisingly disruptive solution, and I'll just dive into the slides and see if I can explain a bit more about what we do. So, disrupting force in space. We all know that space is a exciting industry. It's a large industry, fast growing. But here's to put a number in it. It is approximately 370, some say 380 to $400 billion today. More than half of this value more than half of the $400 billion comes from the satellite services. As I said, it is GPS, weather services, communication, and so on and so forth. Now, these services, since they rely on spacecraft, they're quite reliant, right, on that spacecraft being able to do, to be in control of itself, right, so that it doesn't tumble, so that it doesn't end up flying elsewhere. It needs to be in a particular orbit, and it needs to point in a particular way, and needs to be done quite precisely. That degree of control for a spacecraft requires some kind of force, right? There's only a certain number of forces that we experience in this world, right? 4 or 5 of them. So it is this range of forces that we can deploy to control a spacecraft. Zeno has come up with a way to produce the most dominant, and when I say the most dominant force, I mean the most widely applicable and the most sustainable force for such spacecraft in orbit. Before I explain what that force is, just have a look quickly at this summary, right? When we compare this, the performance of this force to the existing solutions, we end up with at least at least twice the precision for satellite services when it comes to ability of spacecraft to point somewhere and take an image. It increases the mission reliability of spacecraft or a mission by an order of magnitude, 10 times at least, and also provides a great advantage to the customer or to the industry from the pricing standpoint, right? So it is cheaper, much more capable, right? And also allows a great number of new doors to be opened for the industry to enjoy. It happens to be the industry's first breakthrough in the last 60 years. And it's not surprising, because the industry is, although is a quite mature industry, it has spent most of its life being developed, right, and explored by the militaries and the large governments. And it's only recently, in the last maybe 10 years or so, we see businesses come into the industry, and businesses are much more agile, much more eager to succeed, and therefore we see quite a lot of innovation. And Zeno is championing really this innovation when it comes to in-space operations. So a singular product, which is this new force engine. By the way, I'll go a slide back. I'll see what you're looking at here is this new type of force engine, an electromagnetic drive, so to speak, which is powered by the solar energy, generates a strong magnetic field, and interacts with the field of Earth itself, right? Just like two magnets do, interacts with the field of Earth itself to provide useful action in orbit. Just like the needle of a compass interacts with the field of Earth. Similarly, we can turn a satellite into a miniature compass, right? If we simplify things, and then we could derive a lot of good value from it without the pollution of the environment, without the sacrifice of any kind of service, for as long as we need, and it's clean and sustainable. So one innovation leads to a huge industry-wide impact. As I said, we're currently concentrating as a business on the turning force. So we can turn and point spacecraft so that they can do their imaging and communication and survey that they do in orbit. That is a beachhead market for us. We're on the way to enter this market in the next 18 to 24 months. From there, we're looking to also address the protection of spacecraft as well as protection of crew from the charged particle radiation with the use of the same engine, with the use of the same electromagnetic forces that we developed. That is an emerging market for us in the next 3 or 4 years or so. And on the horizon for us 7 years from now is a moving force, right? An ability to move spacecraft and accelerate them or decelerate them in orbit with the use of electromagnetic fields, right? Just like we have a large hadron collider in Europe where we accelerate charged particles, we can do a very similar thing in space. We can use magnetic tunnels, so to speak, to accelerate spacecraft or to slow them down, to remove debris, or to maintain the trajectory of certain spacecraft in orbit without the use of any kind of fuel for that purpose. So the market is expected to be worth north of $1 trillion by 2030. It is today roughly 370, 380. And as we stand today, we expect to address roughly 40% of it in the next 8 years. So far, Zeno has secured in the last 3 months of the last year, secured a few $1 million in pre-sales with the world leaders in space operations, and we are continuing to sell quite actively in this year. When it comes to technology, it's been over 4 years in testing so far. So we've had a number of live tech demonstrations for the US government, for our clients here in New Zealand. We've done a whole range of tests to simulate the space environment. We've done vacuum tests, thermal power, frictionless stable tests to simulate, the zero friction environment, and essentially have come as close as we can to how the technology will operate in space. The nature of this technology, as I said earlier, is the breakthrough in superconductivity, and in particular in superconducting electromagnets. Just for those who do not understand the significance of what superconductivity is, I'll briefly explain how a general magnet works, right? A general magnet always has a magnetic field to it, right? And we're all familiar with it. We've played with a number of magnets when we were kids. Two magnets come together, they push, pull, or turn, right? These are just general magnets, always magnetized and very strong. An electromagnet is like a trick, right? Electromagnet is essentially an ability to generate a magnet on demand. So it's very simple. Only a couple of things are needed for an electromagnet to occur is a piece of wire, and then this wire is coiled a little bit, right? And through those coils of wire, we push electrical current, right? And the nature of this world is such that when you push electrical current through coils of wire, it develops a magnetic field which is indistinguishable from the regular magnet, right? So this is an electromagnet, a conventional one. Now, a superconducting electromagnet has one key difference. The wire which is used in a superconducting electromagnet has absolutely zero resistance, not close to zero, but absolutely zero resistance to the electrical current being pushed through. What does this mean? That means that we can push a huge amount of electrical current through such a wire, which creates a very, very strong magnetic field as a result, unprecedentedly strong magnetic field, orders of magnitude higher than can be done with the conventional technology, right? So this is one of the key innovations in what Zeno does, creating exceptionally strong magnetic fields, right? As strong as the MRI machines, right? But in the size of something that fits in your pocket, so to speak, and doing so very efficiently and controlling such magnetic forces also with great precision. We've been fortunate to be the first ones to think about this worldwide, and Zeno has filed a number of patents in New Zealand, US, and Europe. We have 31 inventive, industrially applicable and novel claims, which essentially allows Zeno to explore any application of any superconducting electromagnet in space. Team-wise, we're quite experienced. We've gone to space before. So myself, I'm the chief executive and I'm the inventor of technology. These days, I'm hands-off with technology. We have Ruben Brown in charge of the operations. Ruben is the person who started the Auckland program for space systems and launched the New Zealand's first spacecraft. Likewise, Francis is our chief technology officer, who was the CTO on the New Zealand's first spacecraft, and Sebastian is my co-founder. The team is much larger than this, but these are the key founding members. We're moving very fast. Starting in 2018. Today we have pre-sales, traction, and technology is mature. And we have just recently, I'm very pleased to announce, just recently closed a seed round, which happens to be the largest seed in New Zealand deep tech industry, the largest seed that New Zealand has ever seen. So in the next couple of years, we'll be launching a technology demonstration mission into space. We'll see our product on the market, and we'll have consistent revenue going forward. So that, in a nutshell, is where Zeno is at today. And thank you very much for your attention. I will try, if possible, to play a video as well, if I still can.
Is there anything about the lunar module that bothers you?
We would always like to have a little bit more fuel, but I think that that's a natural reaction of a pilot.
What would it mean if space exploration wasn't limited by fuel? What if it was electric? We could remove space debris, launch less, pollute less, explore more. The Zeno team have developed an engine which helps overcome the obstacle of fuel. The Zeno magnetic engine can orient and move in any direction, expanding the agility and lifespan of any craft in orbit, giving us more control of the skies, keeping them clean, changing the way we perceive space travel.
Thanks, Max. I've posted what I think the YouTube link is for that video in the chat so that if others want to watch it after the fact, they can go ahead and do so. We've seen a few questions come through the Q&A panel so far, so please make sure that you get those questions in. Again, this is a great way to make sure that your interest and concerns are raised to our speakers so that they can comment and share their perspectives. So at this point, we'll shift gears slightly, and I'd like to introduce Peter Toth. Peter Toth is the co-founder and CEO of Extraterrestrial Power. Extraterrestrial Power aims to become the renewable energy provider of the solar system by providing key enabling solar cell technologies for space and lunar power applications. Peter is a self-described space geek who sees space as the next frontier and works toward a better future, and is also a seasoned software engineer and performance tuner. So with that, I'd like to introduce Peter Toth.
Hey everyone, thanks Jess for the introduction, and thanks Max for the great presentation. It triggered so many thoughts. So let me just try to share my screen and see how that works. Can you see my screen?
Sure can.
Awesome. So to start off, I think I'll try to today something different as a presentation. As I go through the slides, I will try to help a bit entrepreneurs of who looked at starting companies and who looked at doing all this, and maybe share a few lessons learned. And what you see here today is probably evolution number 150 of our presentation. So there has been a lot of things learned in the process. So similar to Max, we've started off looking at volumes in space and where volumes are happening. And the original idea was really nothing to do with solar cells for satellites. It was all about, can you make solar cells on the moon or Mars? And I've asked this question, then looked up Wikipedia. The answer was a clear yes. So that was really nice to see. 44% oxygen in top of the lunar soil, 21% silicon. Woohoo, we can make silicon solar cells on the moon. And that's where our journey began 4 years ago. It was all about making solar cells on the moon. And we've come a long way from that, and we've generalized our vision, generalized our ideas, and realized that solar power is right now almost the only power in space, especially Earth orbit, cislunar orbit. Wherever you go, it's all about solar power. So we've stepped up and said, okay, how can we do something in this arena? So okay, one sec, whether I can change the size. So our vision is to deliver affordable power to humanity in space. Right where I start off here, you can see that there are multiple versions of the vision, but all about space power. And We really want to help humanity. And I think that's a crucial point where we know whom we serve. And we know that the future is exciting in space and the future is growing in space. So we expect that the space market will require 10 times more power within 10 years. It might seem like that we've only just began launching a few more satellites, but the amount of satellites in space is going to skyrocket very quickly in the next few years. And if we consider the next 10 years, there will be space stations, there will be lunar exploration, there will be humans in space. All of this will require enormous amount of power. And what we've seen with satellite solar cells is they exist today. They are a marvel of engineering, but they cost a lot. There is about 1,000 times difference in costs between space solar cells and terrestrial solar cells. And so why is that? So it's complicated to manufacture, reliability requirements are extreme, equipment costs are high, material costs are high. All this together, coupled with the low manufacturing capability, means that not everyone can afford these solar cells if you really want to manufacture satellites in the production environment, in manufacturing satellites rather than one-off, assemble one huge satellite, and the costs are almost no matter. What we've came up with after pivoting from our lunar plans, which are still there in the future, but we've realized that there is an enormous market immediately, and it's a growing market immediately for space solar cells. So we are looking to use terrestrial solar cell technology, which has come a long way in the last 20 years, when last silicon was used in space. And we are coupling that with proprietary light trapping, proprietary technologies to make them radiation tolerant. And we already have the team to make that happen. In terms of stages, what we've realized that every technology development has stages. So we have so many stages in our road to be the renewable energy provider of the solar system, that we needed to isolate, like, okay, this is what we are going to do first. So currently we are working on a silicon-based solar cells, which is very close to terrestrial cells, but it's more radiation tolerant and much cheaper than space cells. Then onwards, we are looking to improve upon radiation tolerance by a lot and make thin cells, but they will take a bit more time to develop. So in terms of solar cells, the market doesn't look like as huge as the space industry itself, but it's going to be growing at an immense pace. And most of the driver for the growth is going to be coming from from satellite constellations. I think today people are talking about 300,000 satellites in low Earth orbit. Just to put it in perspective, today we have 4,000 active satellites. I think 4,000. I'm not sure whether that involves dead, and a lot of space debris as well. So to summarize it, we are looking to make thin crystalline silicon solar cells for space applications, which can be cut to custom sizes and can be ordered in a short time frame, and then will cost much less than the space industry average. This is an interesting slide that I wanted to show how we ended up here. And with Jess's introduction, so basically we are transforming to become an Australian company. and we needed to move from New Zealand. But starting off in 2018, we were all about still solar cells, solar cells made on the moon. We've done some research in New Zealand. We've set up an Australian subsidiary. And then as our evolution of thinking and prototypes improved, in 2020, we came with the realization that if we can make a solar cell that works in lunar environment, why are we not making it for satellites? So we've joined, since then, we've joined 2 accelerators. One is Singapore SpaceBase Limited, and they are a nice group of people with a lot of space companies involved. So that's a really nice place for us to bounce off ideas of friendly companies. In terms of development of the company, we've been focusing a lot on grants. So we've got $1.5 million worth of Australian grant funding. This helps us a lot leveraging all the money that we need to put into the company. And we've also started gathering letters of intent to purchase. And I've sort of learned that on the way of becoming an entrepreneur when I've looked at a company called Relativity Space. I'm not sure whether it is familiar to you. They are a 3D printing rocket company, and they still have not launched anything into space, but they raised an exorbitant amount of money. And what the realization from there was that throughout their journey, even initially, they had a huge amount of LOIs. They've raised Series A, Series B rounds with billions of dollars of LOIs. So that made it easy for them. And we thought that it's good to focus on customers. So we've done something similar. So we are currently working on the R&D of our cells. We are looking to pilot manufacture them next year and fly them. And in 2025, we would ideally be in the position that whether we can decide to manufacture on Earth or we want to manufacture on the moon. Hopefully. So our team is a lot of solar cells people, plus me. I'm coming from, I have a bit of experience in solar cells, a lot of experience in embedded software engineering. We have Bobette, our CEO, customer experience designer, and our personal legal department as well. And we have Dr. Lee Mai, our CTO, who already helped the solar revolution happen on Earth. So we are looking for her to help the solar revolution happen in space as well. And then Professor Gavin Conybeare, who is one of the top 10 solar cell researchers worldwide. And he's also a professor at University of New South Wales. And really the reason why we are here in Australia, because as opposed to many things that you can manufacture, solar cells are a volume game, and it's really expensive machinery that is necessary, which we have within the university campus. And we have our advisors, without whom we wouldn't be here today. And Emmeline and Eric should be on the call today. And Andrew Hoppin as well. They are all Edmund Hillary Fellows, by the way, in New Zealand. Yeah, and so altogether we are great in solar arrays, embedded systems, design, aerospace, and looking to improve ourselves even more. And I have my thanks slide after this, but I thought I'll include one interesting slide that I had from 2020, which is sort of a reality check of what our assumptions were when we started 2018 and what the expectations were for a lunar market materializing. And this is how it looked in 2020. And you can see that out of all of these lendings, only the Chinese lending succeeded. SpaceIL at least tried. Oh, sorry, yeah, that was this is 2021, the second launch. So none of these lendings really materialized yet. So there is always timelines are always a concern in space. And with that, I would like to give it back to Jess, and thank you for your attention.
Thanks, Peter. So at this point, I think we'll get that other screen back up again. Great. So now we've come to the interactive part of our webinar today. If you have questions that you'd like to have answered, please feel free to type them into the Q&A panel. We've got a few come through already, so this will be a great opportunity for our speakers to comment. Max, if you want to turn your camera back on, great. We will we'll get some questions. We'll get some of these questions off to you. So I've got a question for you both. Broadly, just to break the ice here. So breaking into space and the space sector can be quite challenging. Has there been anything that surprised you, either harder or easier compared to what you thought you'd encounter as you've moved into these areas? You know, can you comment on some of the obstacles that you've had to tackle that you both expected or did not expect to encounter?
Pete,
I don't know.
do you have anything to say?
I wanted to say that I'll let you go first on that.
Okay. Very kind of you. Okay, so yeah, space is quite challenging because the industry is reasonably conservative. You know, the cost of failure is very high. It is difficult to enter the industry, difficult to innovate in general, right? So we know this, but when you actually try to innovate within the industry, you feel it on a whole different level, right? So it's extremely challenging to innovate in the industry. It is also challenging to develop a truly new technology as opposed to commercialize an existing technology. Development of new technology requires a few years of R&D process, which of course requires funding, and the funding options for private companies are quite limited. It is exceptionally difficult to convince a VC, a venture capitalist firm, to invest into a company that is in the R&D stage. And also it is not enough, to have the support from the government. It is normally not enough, the amount of support that we have. So the first few years, at least for us, have been quite challenging from the funding standpoint. But once we have cleared that, that first stage, things have become a lot easier. Once the venture capitalists understand what it is that your product is, once they see traction with the market, once they see the real thing and how it works, it's a lot easier for them to make up their mind.
Yeah, I feel it's quite similar in the funding front for us. It's starting off, and I've seen a question here from an anonymous attendee that what was the factors behind becoming an Australian company, is partially funding. So partially the fact that we need to be in Australia because the equipment is there, but partially because there is more funding available. And we've tried a long time in New Zealand, but a lot of things didn't materialize for the space industry and for startups that we were hoping for, which exists in Australia. So hopefully those parts are behind us. So we've we won a few grants in Australia, which helped kickstart a lot of things in parallel. So that's been great. The industry in general, it was interesting being out of the last 4 years, being 2 years in lockdown in New Zealand, and that you cannot travel. And to be fair, I feel like that opened up many possibilities within the industry as well, because the traditional space industry, which is like, oh, if you come here, then you exist, otherwise you do not. But then if their own employees cannot go on premises and they are working from home, it's so much easier to talk to them from New Zealand even. It doesn't matter anymore. So there have been pluses, minuses, but altogether, I think the industry is changing, and the industry is, there is like a new part of the industry that is much easier to engage with. Yeah, that's about it, I think.
Thanks, Peter. There was another question that came through right about the same time, asking about the Australia versus New Zealand comparison. I see that's been tagged. There is a question, does data science play a big role into making your companies work? Max, you'd flag this one as one you'd like to answer.
Yeah, sure. It's a good question. So data science is a reasonably significant component for us in particular. We've had to rely on data scientists, early on to help us with development of certain models that we use to understand how our engine operates in orbit, how it interacts with the rest of the environment, and in general, we see more demand for data scientists, within Zeno going forward. So yes, it is something that is useful in the industry, and if there is any interest, please feel free to reach out to us. We're always happy to hear from data scientists because we're constantly hiring.
Thank you. Let's see. So I've got a question for Peter. Radiation tolerant electronics are hard. What's your thinking about how to measure or even mitigate radiation effects? What are you thinking about in terms of your planning for qualification and evaluation of your designs in that regard?
So to start with, solar cells are not electronics. It's a huge diode, really. So electronics, you can have a bit flip, you can have a damaged gate, you can have all sorts of things. But a solar cell, in essence, is an analog device. And with analog devices, things get simpler and more difficult. For radiation tolerance testing, with solar cells, to be honest, it's quite easy. You have to have the facility to do it, which means that we have to ship it around the world for radiation testing. But within less than a day, we can put as much radiation into the solar cell as it would be 15 years in geosynchronous orbit. So that makes it quite easy to test. And then your results come back and you can see what's going wrong. Obviously, it's a bit different because the testing is never perfect for the same environment, and that's why flying things in space is equally important, because that's when your electron radiation, your proton radiation, your galactic cosmic rays, your atomic oxygen, what else? Your thermal vacuum cycles and everything comes at you at the same time. And there is no real substitute for that. But in terms of electronics, it's a whole nother world of how that can be tested. And I've just recently been to a workshop on how to radiation-proof electronics, and there is a lot of movement in there and how you can actually test very specific parts of the chip for radiation tolerance, and that's brilliant. But it's I think it's a bit off the point for now. But feel free to ask me in private if anyone has questions about that.
Thanks, Peter. I think a question's come through the panel. Look, based on the subject, I think it's aimed at Max. Does one of the aggregates you showed control all axis, or do you have to have multiple of them, e.g. one per axis?
Smart question. Yes, and a good guess. We do require multiple, well, essentially one per axis, and if we require 2 or 3 axis control, then we have to have 2 or 3 orthogonally positioned coils in the system. This coil, it's attached to a stand, but you can see the size of it, right, is approximately comparable to this conventional magnetic torque rod, which is roughly 7 kg in mass, and it's quite long, therefore determines the dimensions of the spacecraft. So yes, multiple coils, if multiple axis control is required, but still very competitive with the conventional systems. In fact, in some cases, we'll look to replace also the reaction wheels or the flywheels, which I'm not going to dive deeply into, but I presume Carsten understands the definition and the and the use cases of those.
Thanks there. Got a question for you both, shifting topics a little bit. Your teams are pretty diverse in terms of background and experience. What skills or enablers do you see as being important to your success, either success in getting to this point or success going forward? Peter, do you want to comment there?
I guess it's love and resilience. So, we are here today, 4 years after we've started, and if I would not have loved what I'm doing, and I would not have wanted to do it madly, it's we wouldn't be here today. And yeah, it's like for us, most of the time in the last 4 years, or for a long time, it was only a part-time gig, because that's what Max said about the funding problem. You have to live off something, and then you have to push your dreams. But today we are in a bit more comfortable position. But then the journey is on, and that's great to be a great place to be.
Max, any comments on skill mix, either in reflecting back on the path that's gotten you to where you are, or what you might need going forward?
Yeah, so from the standpoint of talent and people, we've always been engineering heavy. So the founding team is pretty much all engineers. But going forward, building a business is different to building an R&D sort of workshop and R&D sort of project. So we're a bit more diverse today, and we're looking to diversify even further going forward in the next 12 to 24 months. So we'll be hiring people on the business development front, project management front, and so on. Another thing that we're quite careful about at Zena is ensuring that we provide a healthy environment for our people, to operate within. So we do not, glorify long hours or hard work. We appreciate effective work, you see, because simply sitting here for a long time getting tired and decreasing the quality of your decision making is not valuable to the company. So we advocate short bursts, energetic bursts of work, by well-rested people who are passionate about what they do, right? That has been our motto since day one. Sometimes we fail, of course. Sometimes I find myself having to push a little bit, right? But there is no glorification attached to that, right? We understand that if we have to push over time, that something has gone wrong. We didn't plan well enough ahead, and being overextended is no good. So far, it's worked for us, and we are looking forward to implementing this, as one of the core rules, so to speak, going forward.
That's great to hear. And I sort of second that. So it's really important that people can make decisions, and diversity of people we have is quite important, because then there is always a different viewpoint, and we need to agree on many things. We do not need to agree on everything, but that helps the company propel forward.
Thank you both for sharing your thoughts. There's been a question that's been asked, and I'm going to rephrase a little bit just so that it's open a little more broadly. So what, if anything, would you say would improve the landscape for space startups, particularly in New Zealand, but feel free to answer as broadly as you'd like. Maybe Peter, you could start us off.
So improved in the start. So what improved in the startup landscape?
Yeah, what would make your life easier as a startup in a space technology startup? I know there was some discussion early on about funding, and I recognize that that's probably a big part of it, but perhaps you can either comment further or
yeah,
expand.
I think funding is probably the key, and getting from, I think for me, I've been an entrepreneur before starting the company, so I sort of knew what's happening in startup landscape, but I knew that it's difficult in New Zealand, but then I didn't know that it's this difficult. So when you start off from the idea, getting from idea to, okay, we can now work on the idea, and getting it from 0 to 1, that has been really the biggest step. And it's like, okay, now we have a crystal clear thing, what we are working on. We know that we've talked to people. And in terms of support, that early support we felt was really missing. So, from venture capital firms, like getting anything on the lunar side is like, oh, it's too far away. We can't deal with you. From New Zealand government, there was, I think, only a single grant funding opportunity in the last 4 years, which was open to universities and Crown research organizations, which are Crown funded. And as a startup, you are submitting a proposal and you are against Crown funded organizations. So that we felt was really difficult to reconcile, and we didn't. That's why it took us so long to get where we are at today. So what would have helped? These early stage support would have helped a lot if we have access to it. I'm not quite sure about the shapes and forms of how that was, what would be ideal, but it would have been good.
Yep. So I'll add to Peter that early stage support is of course necessary. Probably impossible to make it without the early stage support. In terms of the form and shape, I think mentorship is very important. Learning from those who've done something analogous and comparable in the past, and have done it here in New Zealand, because doing it in a different environment is a whole different story. So don't see really a way to catalyze this in any way. But just knowing that mentorship is is probably the biggest support for an early stage company. I think that's important to understand. From there onwards, funding, availability of funding, but availability of funding is, I think, conditional on conditional on understanding within those who provide, within the organizations that provide such funding. So be it New Zealand government or VCs, the organizations must have understanding of how the industry works. So they must have prior experience. And again, I'm not sure how to catalyze this process. It's just a matter of going through it. Every single startup that raises money in New Zealand in the aerospace domain teaches both the VCs and the government and all involved about what it takes. So just a matter of seeing things through and continuing to support both the VCs with the government money and also the startups with the R&D resources for them.
Yeah, maybe to one step above is that's why most companies know each other and help each other. So yes, we talk with Max often and exchange ideas, exchange experiences. We are almost running our mini accelerator between the two of us of what can we help each other with at times.
Yes, there's only a handful of us, not only in aerospace, but in general, entrepreneurs in New Zealand. There's a pretty small community, so yeah, helps to be on good terms with each other.
Thank you both for sharing your thoughts. I think that's probably all the time we've got for Q&A. So if I could get the slides to advance by one. Again, thanks to both Max and Peter for sharing your insights with us today. And thank you to our audience broadly for your time and attention. We hope that you'll join us at the next webinar in May featuring space systems from Zera and Space Ops New Zealand. Save the date info will come soon. If you've got questions, comments, feedback for our speakers or on this webinar series, contact information is available in this slide. Emails are here. We look forward to hearing from you and we look forward to seeing you all next month. Peter, Max, again, thanks for your time. And
thank you, Jess, for organizing, and thank you all for attention. Thank you very much. Cheers. Bye-bye.
Thanks for having us. It was great to be here.
Awesome. Thank you.
Thanks for listening. Bye.